Hello everybody and welcome to today's lesson on the quadratic formula. Today we will solve a quadratic equation using the quadratic formula, and we will also calculate the discriminant to determine the nature of the roots. So let's review. What methods have we used to solve quadratic equations so far? The first thing we did is we solved them by graphing. Just graphing our parabola and seeing where it crosses the x-axis. We also spent some time using the factoring method to find our two solutions. And in our last class, we talked about completing the square. Today we will spend some time talking about the quadratic formula, but the quadratic formula is really a review of Algebra 1. You have learned it and used it already in Algebra 1, so I'm sure it'll come back really fast. The quadratic formula needs our equation to be in standard form and all terms on the same side. So if ax squared plus bx plus c is equal to 0, and the equal to 0 is the important part here, then our solutions will be negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, I know that formula looks a little complicated, but the most important thing about it is to really put the numbers in the right place and not get confused with all the minuses. There is a way to derive this quadratic formula, and the way you do it is by going from your equation in standard form and using the completing the squares method. If you want to go right ahead and try out if you can do it yourselves, I'm also happy to show it to you in class. But for now, let's look at how we apply the quadratic formulas to find our solutions. So let's write down our quadratic formula one more time. That always helps to know which number to put in which place. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. In our first example, we have a is equal to 1, b is equal to negative 9, and c is equal to 5. Always get started by writing down the numbers for a, b, and c, so you don't get confused as you put them into this formula, which does look a little involved. So then we get x is equal to the opposite of negative 9, which is positive 9, plus or minus the square root of negative 9 squared, minus 4 times 1 times 5, all over 2 times 1, which is 2. Let's just continue simplifying. X is equal to 9 plus or minus the square root of 81 minus 4 times 1 times 5, which is 20, over 2. X is equal to 9 plus or minus the square root of 61 over 2. And as I see that, I notice that I put a little 0 here, up here. This, of course, has to go. All right, bad 0. All right, so we can't simplify a square root of 61 any further. So these are our two solutions. And why do I say two solutions? Remember, we are taking the 9, and one time we're adding the square root of 61 to it, and one time we're subtracting the 61 from it. So the quadratic formula has this built-in thing that always will give us two solutions if we get a value to subtract or add in the latter part of the formula. In our next example, the equation is not yet in ax squared plus bx plus c is equal to 0 form. In other words, we don't have 0 on the right side of the equation. That means we need to do this. We need to subtract the x squared, and we need to subtract the 7 from both sides each time. And then we end up with an equation that says 2x squared minus 4x minus 7 is equal to 0. And only now can we actually take the values for a, b, and c. So be careful with that. You're going to be sure to have equations where you have to do this first step first. So now we can find the values for a, b, and c. A is equal to 2, b is equal to negative 4, and c is equal to negative 7. That means x is equal to the opposite of negative 4, which is positive 4, plus or minus negative 4 squared minus 4 times 2 times negative 7 all over 2 times 2. Let's continue simplifying. X is equal to 4 plus or minus the square root of 16 minus 4 times 2 times negative 7. That makes it a positive number, positive 56, all over 4. X is equal to 4 plus or minus the square root of 72 over 4. Now the square root of 72 can be simplified. Let's make a little factor tree here. 72 is 36 times 2, and yay, 36 is a perfect square. That means we can pull out the 6. X is equal to 4 plus or minus 6 times the square root of 2 divided by 4. And now we are in luck again, because all numbers here, the 4, the 6, and the 4 in the denominator, can be divided by 2. So x is equal to 2 plus or minus 3 times the square root of 2 divided by 2. And this is our final answer. Now let's talk about the discriminant. The discriminant tells us the nature of the roots of a quadratic function. And the discriminant is that part under the square root. In other words, the b squared minus 4ac. If the discriminant b squared minus 4ac is greater than 0, then we have two real roots. And there can be two different possibilities. If it is also a perfect square, then the two real roots are rational roots. If that number is not a perfect square, then we have two irrational roots. If b squared minus 4ac is equal to 0, then we have only one real rational root, and we also call this a double root. Now, how is that possible? Let's look back at our formula, right? B squared minus 4ac is under our square root symbol, under our radical, and it's going to be added or subtracted to the negative b in front. Well, if there's nothing there, if it's 0, then we're adding or subtracting 0, and that means we don't get two different answers. We get just one answer, and this one we call a double root. And it's going to be a real rational root. And last but not least, if b squared minus 4ac is less than 0, if it's a negative number, then we're going to have two complex roots. Because, again, let's look at our formula. If the number underneath here, our discriminant, is a negative number, we're taking the square root of a negative number, and that's why we even went and learned about the complex numbers, because that's the only way to solve the square root of a negative number. So what would that look like for our parabola when we graph it in a coordinate plane? So in the case that b squared minus 4ac is greater than 0, we would have a parabola that crosses the x-axis twice, maybe opening up, maybe opening down, but it would cross the x-axis twice, and we would have two solutions, two roots, two x-intercepts, and two zeros. If b squared minus 4ac is equal to 0, well, then our parabola would just touch the x-axis and go back up, in this case, or go back down, in this case, and we would only have one root, which we call a double root. And if b squared minus 4ac is less than 0, if it's a negative number, that means that our parabola will actually never cross the x-axis. Either it opens up and never goes down far enough to touch or cross the x-axis, or it opens down and never comes up enough to cross that x-axis. That's what you're going to see if you graph quadratic functions with the numbers arranged like that, that the discriminant would be in the respective form. We can calculate the discriminant from the numbers in our equation to find out about the nature of the roots. Looking at our first example, first let's find a, which is 1, b, 2, and c is equal to -6. And remember that our discriminant is b squared minus 4ac. Now let's plug in the numbers, see what we get. 2 squared minus 4 times 1 minus -6. 4 minus -24. In other words, 4 plus 24, 28. 28 is a positive number, and it's not a perfect square. Therefore, we have two real irrational roots. And the fact that they're irrational also means that we could not have come up with that answer with methods just like factoring. We can't factor any trinomials where the answers are irrational roots. Also with graphing, it would have been hard for us to really see the number because the parabola doesn't cross the x-axis directly at a grid line. In our next example, a is equal to 1, b is equal to 6, and c is equal to 11. So we have 6 squared minus 4 times 1 times 11. 6 squared is 36 minus 44, which is -8. And that means that in this case we're going to have two complex roots. Two complex roots, and yet again that means that our parabola will not cross the x-axis. And since we haven't solved a problem yet where we would end up with complex roots, as a little bonus, Let's do this right now with this problem. You can do this in the left margin of your notes page. X is equal to negative b, which is negative 6, plus or minus. Fortunately, we do not have to calculate the discriminant anymore. We already know it's negative 8, and all that divided by 2. Now, let's think about the square root of negative 8. The square root of negative 8 is the square root of negative 1 times the square root of 8. We know that the square root of negative 1 is I. That's what we need the complex numbers for. And our square root of negative 8, we can draw a nice little factor tree and find out that we have 2 times the square root of 2. Well, that makes it easier. So let's then go ahead and write x is equal to negative 6 plus or minus 2I times the square root of 2 all over 2. And yet again, we have the 6, the 2, and the 2 that can all be divided by 2. X is equal to negative 3 plus or minus I times the square root of 2. Do we need a denominator? The denominator would be 1, so we don't really need a denominator anymore at this point. And here are our two solutions. We have x is equal to negative 3 plus I times the square root of 2, and x is equal to negative 3 minus I times the square root of 2. That's it for today, and I will see you in class.